Question 1. What's the difference between Callable versus Runnable? Runnable and Callable are both interfaces used for executing tasks in multi-threading, but they have key differences. Runnable is a functional interface that represents a task that runs on a separate thread but does not return a result or throw checked exceptions. On the other hand, Callable allows a task to return a result and throw checked exceptions. This makes Callable more suitable for tasks that require computation and need to return a value, while Runnable is useful for tasks that execute independently without needing to return anything. Question 2. What is Executor Service and why we need it? Executor Service is a framework in Java that provides a higher-level API for managing thread execution. It helps in efficiently handling a pool of worker threads instead of manually creating and managing threads. This improves performance and resource management by allowing task submission, scheduling, and lifecycle control. It prevents excessive thread creation, optimizes CPU usage, and simplifies concurrent programming by handling task execution in a controlled manner. Question 3. Describe when you would use Async and Executor Service to improve the performance of your web application. The Async annotation in Spring allows methods to run asynchronously in a separate thread, making it useful for handling non-blocking operations such as sending emails, logging, or background computations without affecting the main application thread. Executor Service is used when we need fine-grained control over thread management, such as defining a fixed thread pool to handle a high number of concurrent tasks efficiently. Using both approaches improves web application performance by reducing response times and ensuring efficient resource utilization. Question 4. Explain the difference between Future and CompletableFuture. Future represents the result of an asynchronous computation, but it has limitations, such as the inability to manually complete a task or perform chaining and error handling in a declarative way. CompletableFuture, introduced in Java 8, extends Future and provides additional functionality, such as chaining multiple tasks, handling exceptions, and composing multiple asynchronous computations using methods like thenApply and exceptionally. CompletableFuture improves asynchronous programming by making it more flexible and readable. Question 5. Can you list several Java built-in functional interfaces and their usage? Java provides several built-in functional interfaces under the Java util function package. Predicate is used for testing conditions and returns a Boolean. Function is used to transform an input into an output. Consumer is used to perform operations on an object without returning a result. Supplier is used for providing values without taking input. By function takes two inputs and produces an output. These interfaces enable functional programming and make code more concise and reusable. Question 6. What is the difference between asynchronous programming and multithreading? Asynchronous programming allows tasks to run independently without blocking the main thread, improving efficiency when handling I/O-bound operations such as database calls or network requests. Multithreading, on the other hand, involves running multiple threads in parallel, sharing CPU resources. While multithreading is suitable for CPU-intensive tasks, asynchronous programming is useful for handling non-blocking tasks efficiently. Both approaches improve performance but are used in different scenarios depending on the nature of the workload. Question 7. When creating a thread pool, how do we decide the size of our pool? Please explain your approach at calculating the pool size. The optimal thread pool size depends on the type of tasks and system resources. For CPU-bound tasks, the pool size is typically set to the number of available CPU cores to avoid excessive context switching. For I/O-bound tasks, a larger thread pool is recommended because threads spend time waiting for I/O operations to complete. A general formula for I/O-bound tasks is number of threads equals number of CPU cores, 1 plus wait time, compute time, ensuring that CPU resources are efficiently utilized while handling multiple I/O operations concurrently.